This video is over section 10.1, graphs of systems of linear equations in two variables. This first section says determine whether the ordered pairs are solutions to the system 3x plus 2y is equal to negative 8 and y equals 2x minus 18. So really quick off to the side, a point. I'll say in order for an ordered pair to be a solution to the system, it needs to, I'm going to put it in quotes, work, because that's not super mathy, in both. I'm going to rewrite that in all caps. Both equations. Okay, so for an ordered pair to be a solution to the system, the ordered pair needs to work for both equations. All right, so for this first one, we have negative 2, negative 1. So the negative 2 would be the x. The negative 1 would be the y. I'm going to check it in the first equation first. So that would be 3x plus 2y is equal to negative 8. 3x plus 2y is equal to negative 8. And we're plugging in negative 2 for x and negative 1 for y. So that would be 3 times negative 2 plus 2 times negative 1 equals negative 8. And I'm going to put a tiny question mark above the equal sign because we're not sure. We're checking that. So when I multiply this, I get negative 6 minus 2 is equal to negative 8. And that is true. So I'm going to put a check there. However, we can't stop here and say that it works. It needs to work in both. So I'm going to now check 2x minus 18. So I have y equals 2x minus 18. And when I plug in my x and y, I'm going to have negative 1 is equal to, with a question mark because we don't know, 2 times negative 2 minus 18. And when I multiply that out, I have negative 1 is equal to negative 4 minus 18. And that is not true. So I'm going to put a little x here. So that would mean negative 2, negative 1 is not a solution for the system. Sorry, that got off. I'll slide it to the left. Okay, so because it did not work in both, that means that negative 2 is not a solution for the system. It works in the first one, not the second one, so it's an all-around no. All right, we're going to do the same thing for 4, negative 10. So x is 4, y is negative 10. We're going to check it in this top one first. So that is 3x plus 2y is equal to negative 8. When I plug in x and y, I'm going to have 3 times 4 plus 2 times negative 10 is equal to, with the question mark because we don't know, negative 8. When I multiply that out, I get 12 minus 20 is equal to negative 8, and that's true, so I'm going to put a check mark. However, we cannot stop. We need to try both equations to make sure that it works in both. So I also need to try y equals 2x minus 18. When I plug in x and y, that will give me negative 10 is equal to 2 times 4 minus 18. And I'm going to put a little question mark because that's what we're checking. So that would be negative 10 is equal to 8 minus 18. And that's true as well. So I'm going to put a little check mark. So because 4, negative 10 worked in both equations, that means 4, negative 10 is a solution for the system. Great. Okay, so this video is really about what that looks like graphically. And so there's 3 scenarios that could happen if we're looking at graphs of these. The first scenario would be that the lines intersect. So if the lines intersect right there, for example, that means that the system has one solution. So I'll say system has one solution. And it would just be that orange dot right there. If the lines are parallel, you notice they never cross. That means that the system has no solutions. So they never cross. And then the last one, both equations are the same line. So say you graphed the first one, you graphed the second one, and you get the same line. So that means that it crosses in every single place. So that means that the system has infinitely many solutions. Meaning that every single point on that line will work. Okay, great. So let's look at these 4 graphs and see which of these 3 categories they fall into. So we need to graph each of these. So I'm going to graph this first one in blue. So I'm going to put a blue, I guess I'll put a box around it. So this one is already in slope-intercept form, so I need to graph the intercept at -5. And then my slope is -3, so that means down 3, right 1, or up 3, left 1. And I'm going to do as many dots as I can so I have a very neat line. I'm going fast on graphing because this should be a review. If you have trouble, I'll try to post a different video with that. For the second one, I'm going to use pink. However, this is in standard form, so it's a little tricky to graph, so I'm going to go ahead and switch it to slope-intercept form because that's easiest for me. If you can graph from this form, great. It's actually pretty quick to graph from this form, but just for review's sake, I'm going to go ahead and review how to switch the form on this one. So if I have x minus 2y equals -4, I'm going to subtract x. And that leaves me with -2y is equal to -x minus 4. I'm going to divide by -2. And that leaves me with y equals, and remember here, we need to divide both things by -2. That leaves me with 1/2 x plus 2. So I'm going to graph that. So my y-intercept is 1/2, or 2. My slope is up 1 over 2. And again, I'm going to do as many dots as I can to the right so my line is super neat. And I'm going to do the same thing to the left. When I connect the dots, I can see that the solution for this graph is right there. I'm putting an orange dot there. And the solution for this system is the point -2, 1. And if we wanted to check our answer, I guess let me use a different color here. So just a side note, to check our solution, I'll put answer just because it's, to check our answer, we can plug in to both equations. Okay, so if -2, 1, we could plug it into both of the equations and it would work. Or we did something wrong. All right, coming over to this next one, I have f of x equals 1. I'm going to graph that in blue. This one has no x, so that means that the slope is 0. So I'm going to go through a y-intercept of 1, but since I have a slope of 0, it's just going to be a horizontal line through 1. Okay, and then I'm going to use pink again to graph this bottom one, and this one is already in slope-intercept form, so, oops. So when I do that, my y-intercept would be 4. My slope would be down 3 over 1. And again, I like to do as many dots as I can so it's nice and neat. And I'm going to connect the dots. And I'll use orange to show that that dot right there is where they intersect, so that would be the solution. So for this one, the solution is at 1, 1. So if I plugged in 1, 1 into the original system, it would work for both equations. All right, next one I have 2x equals 2y. So I'm going to graph that in blue. I am going to come down here just to make it a little bit easier to graph. If I have 2y equals 2x and I divide both sides by 2, I have y is equal to x, which that looks really weird, but all that means is the y-intercept is 0 and my slope is 1. So it's going to give me this line here. Connect my dots. So that's the first line. Then I'll grab pink, and I'm going to graph the second line with pink. But again, this one is in standard form, which is okay, but I'm going to switch the form to make it a little bit easier if it's been a while since you took Algebra 1 where you were doing a bunch of graphing. It's just easier to switch the form. So I'm going to add x to both sides, and I get y is equal to x plus 3. And when I graph that, my y-intercept is 3, and my slope is 1. So up 1 over 1 gives me these dots, and then down 1, left 1 would give me similar dots in the other direction. Connect all the dots and draw arrows. Notice here that the lines never cross, and they could cross off the page, but these will not. So this one has no solution. And let me take a second to explain that. The reason why this one has no solution is that here I have just an x, so that means my slope is 1. And then here I also have an x, so the slope is 1. However, for this pink line, we start at 3. So these lines are never going to hit each other because the slope is exactly the same. And then one starts at 0, one starts at 3. They're never going to cross because they started at different places. So that one has no solution. All right, for this last one, I'm going to use blue to graph the first line. It's already in slope-intercept form, so I can start with the dot at 1, and then my slope is up 1 over 2, or down 1, left 2, to get as neat of a line as I can. I'm going to connect my dots, and then I'll use pink for the second line. Again, this one's not too hard to graph directly from standard form, but just as a review, I'm going to go ahead and switch the form. So x minus 2y is equal to negative 2. First, I'm going to subtract x. And I'm left with negative 2y is equal to negative x minus 2. I'm going to divide both sides by negative 2. And again, remember when you divide the whole side, you have to divide both pieces by negative 2. And so that will give me 1/2 x plus 1. And so when I come over here to graph, I quickly see that I'm going to get all of my dots exactly on this line. So what ends up happening is that this ends up being the exact same line twice. And so that means that every single dot on that line is a solution. So this one has infinitely many solutions. So any dot that you could ever think of with real numbers, x and y, on that line is going to work for this because they're the exact same line.